Forces have always been around since the beginning of time. They speed us up, slow us down, and even keep us firmly on the ground. Like many others, I am sure you are wondering, what is a force anyways? Well, according to Newton's work, a force is a push or a pull upon an object resulting from the object's interactions with another object. What does it all even mean? Well, let's look at different forces to figure this out. The most commonly recognized force is gravity, or Fg for force of gravity. It is a natural phenomenon by which all physical bodies attract each other. It is recognized as a force that gives weight to physical objects and causes them to fall toward the ground when dropped or thrown from a height. This is the reason we come back down when we jump up and a ball eventually hits the ground again after being thrown. Like other forces, gravity, or Fg, is measured in newtons. 1 newton is equal to 1 kilogram times mass per second squared. On Earth, the numerical value of gravity is always the same, 9.81 meters per second squared, or 9.8 for short. The force of gravity, however, can be calculated using the equations Fg equals mg, or Fnet equals ma, where m is the mass of the object the force is being applied to in kilograms, and g or a are the numerical value of gravity itself. Together, you solve Fg in newtons. Assume that you wanted to know the force of gravity acting on your iPhone 5 with a mass of 0.0143 kilograms. Since Fg equals ma, then Fg is 0.0143 kilograms times 9.8 meters per second squared. Therefore, the force of gravity acting on your iPhone 5 is 0.14 newtons. However, there is a large misconception many do not know. Among Newton's many works, he came up with 3 laws of motion. An object remains at rest or in constant velocity when the forces are balanced, or Fnet equals 0. If an unbalanced force acts on an object, the object accelerates in the direction of the force. And for every action force, there is an equal and opposite reaction force on some other body. The normal force, also known as Fn, is the opposite reaction force to gravity. It is not as commonly known due to the fact that it only counters gravity and does not exceed it. Looking back at Newton's 3 laws, since in the last example, the force of gravity acting on the phone was 0.14 newtons, and the phone did not fall through the ground, then Fn must be equal to Fg, meaning that Fnet was equal to 0. Unless the phone was falling in midair, we can always assume that the normal force is equal to the force of gravity, or else we would be falling through the ground, since Fg would be unbalanced. Now, having learnt about the common misconception of forces, we can use a free body diagram to show it. A free body diagram is a diagram which represents all forces acting on an object. As you see, the arrows point in the direction which the force acts in. After learning about more forces, we will add to this diagram. The applied force is also very common next to gravity. The applied force, also known as Fa, is an external force acting on an object. Whether it's someone or something pushing an object or pulling it, the applied force is also Fnet equals ma, where Fnet is the total force acting on an object, m is the mass of the object, and a is the object's acceleration. The last force we should know to answer our initial question is friction. Friction, also known as Ff, comes in 2 parts, static friction and kinetic friction. Static friction is the force it takes until the object starts moving from rest, while kinetic is how much force you need to keep it moving. The equations for this are Ff equals mu times Fn, where Ff is the force of friction, mu is the coefficient of friction, and Fn is the normal force, which is equal to the force of gravity. Just like the normal force and gravity, the FF and FA are often parallel or opposite to each other. Now that we have learned about the forces, it's time to apply them. When dealing with multiple forces, depending on the problem, the forces should be given a direction, which states whether they will be positive or negative throughout the problem, just to keep it simple. Take this problem for example. Mr. Bruni pushes a truck with a mass of 500 kilograms with a force of 410 newtons. There is a 90 Newton frictional force acting on the truck. What is the resulting acceleration of the truck? We know that the mass is 500 kilograms, the force applied is 410 newtons, and the force of friction is 90 newtons. We also know that we're looking for the acceleration. First, we need to draw a free body diagram and give each force a negative or positive direction. In this case, the truck is expected to move to the right. So FA is positive, and since gravity pulls it down, we need Fn to be positive as well. Since the truck is neither floating nor falling through the ground, the Fnet in the x direction is 0, since according to Newton's first law, the forces are balanced. Since both the FA and FF are given to us, all we need to do is plug them into Fnet equals FA minus FF. The answer is 320 newtons. We then plug this answer into Fnet equals ma to find the acceleration. After a bit of math, the acceleration of the truck is 0.64 meters per second squared, and therefore the problem is solved. When reanalyzing what we know, we can answer our original question. By looking at what we have learned, we see that forces in fact are pushes and pulls. Gravity, for example, is a pull since it pulls us down, while Fn is a push since it balances out gravity and keeps us up. Friction is a pull because it pulls us back, while applied is both because it moves us and acts on us like all forces do.